This video is brought to you by Squarespace. Here's a simple code example. This class is a weather service that retrieves weather information from an API, weatherapi.com. Now, you might wonder, how do you actually write tests for this? It's kind of hard, right? Because this does an HTTP request, so you can't really test that without actually doing the HTTP request. This is probably part of the code that you actually want to test, whether you're getting the correct JSON data and that it has the current object and the temperature object. So how do you test those? In this video, I'm going to show you how to write tests for code like this, what monkey patching or mocking is and when you use it. And I'm also going to cover a few advanced testing strategies, as well as a few tips to help you write better tests for your Python code. Because writing tests for your code might seem daunting or not necessary, but actually software tests are really helpful, especially once things get serious in production. Let's go. One of the main types of tests that you hear a lot about is unit tests. And what these do is that they validate the behavior of a small, isolated piece of code. That's usually a single function or method. These unit tests are typically fast, deterministic, and easy to run. Now, why would you actually write unit tests? Well, of course, they catch bugs if you write them well. They make refactoring safer because they provide a sort of safety net for you in order to make sure that when you make changes that things don't break, that you didn't expect to. And often that can happen, that you change something in one part of the code, but you didn't realize it actually affects a completely unrelated part of the code, or actually it was not as unrelated as you thought it was. Another thing that unit tests do is that they also document how your code is supposed to behave. So they're sort of a specification of the behavior of your code. And that's of course also very close to what happens with test-driven development, where you actually write the tests before you write the code. And then the tests give a specification of what the code is supposed to do. Are unit tests the only type of test you should do? No, of course not. In production systems, there's plenty of other different types of tests. For example, end-to-end tests to help verify complete user workflows, or security tests to help you protect against vulnerabilities, or data consistency tests to make sure that your data stays reliable. So unit tests are just one type of testing, but they're not the whole thing. And something else I want to mention is that writing software tests is not an excuse to write sloppy code and then just tweak it until it works. It's really important that you think things through before you actually start coding. I'm not saying you should go full on waterfall methodology, but use your brain a bit and make sure you understand how everything is supposed to fit together. Good design is really important and actually often leads to code that is easier to test. So they go hand in hand, good design and good test. If you look at Python specifically, it comes with a built-in unit test module. So technically, you don't even need anything else to start writing tests for your Python code. However, I always recommend using Pytest. This lets you write your tests as simple functions in modules. It provides more options with assertions. Overall, it's much more capable and pleasant to use than unit test, in my opinion. Now let's take a look at this WeatherService class. So if we want to test this getTemperature method, it means we need to do something about this HTTP request, because we don't want to do that request every time we call that method in our test code. So one thing that you can do to avoid that problem is by using something called monkey patching. And that basically means that you're dynamically replacing a function or attribute at runtime. Why is this called monkey patching and not elephant patching or raccoon patching? Well, I'm not really sure, but it kind of comes from the idea that you're sort of doing something that you're not really supposed to be doing. But for tests, sometimes you can't get around it. So how do you then write a test? Well, here's an example of how you could do it with Pytest. So I've created a test file, test weather patch, because we're using monkey patching. And I'm importing the WeatherService class from the weather module. That's the code I just showed you before, importing Pytest and some typing things that we're going to need. And then you can see we have a single test function, test getTemperature with monkey patch. And interestingly, this gets an argument of type pytest.monkeypatch. And that's the object that we can use to do monkey patching while we're testing. And you see this in action here. So I'm using the setAttr method in the monkey patch object to replace httpx.get by another function. And that's actually a function that I defined here. So this is kind of a replacement function, right? And what this does, very simple, it gets URLs and parameters, just like the regular get function in HTTPX. It creates a class, fake response, that has arrays for status and JSON, just like the object you would regularly get. And then it returns an instance of that object. As you can see, there's already a temperature pre-filled here in the JSON data. So this doesn't actually call any other REST API. This purely sends a response back. So we replace httpx.get by fakeGet. Then we can proceed as usual. We can create the weather service with the API key, and then we can get the temperature in Amsterdam. It doesn't really matter, it's not being used. And then we assert that the temperature is 19. So now we've actually written a test that tests the part of processing the response from the weather API. And let me run this test, and as you can see, the test passes. So this works as expected. And by the way, if you call the weather API for real, we can do that by just running the main script. Like so. And now we can see that the current temperature in Amsterdam is 23.1 degrees. Now I'm not based in Amsterdam actually. Maybe I should replace this by Utrecht. Let's see if we get anything different. No, it's the same. So Netherlands is really small. Anyway, that's monkey patching. We're replacing something with a fake something else so that we can run the test accordingly. Now, as you can see, it's not that hard to do this, but it is a bit annoying to have to do that. Also, you need to keep track of the things that you actually replace, not forgetting to replace something that shouldn't be called in the test. So it's, yeah, I wouldn't say this is the ideal way to write tests. And actually here there is a different way to write tests for this. But before I show you how to do that, first I'd like to take a moment to talk about today's sponsor, Squarespace. Squarespace is an all-in-one website platform designed to help you stand out and succeed online. Whether you're just starting out or scaling your business, it gives you everything you need to claim your domain, build a professional site, grow your brand, and get paid all in one place. I've used Squarespace myself to launch websites for my businesses. And as someone who builds software and teaches software design, I really appreciate tools that are thoughtfully designed and just work. It's really easy to get started by using Blueprint AI, which generates a fully custom website based on just a few prompts. There are a ton of templates that all look really good. After that, it's trivial to add sections or change the appearance to your liking. And boom, you have a full professional website. Squarespace comes with integrated SEO tools, so you don't need to worry about optimizing meta descriptions or generating sitemaps. It handles all of that automatically. If you ever try to get a new dev blog or documentation site indexed properly, you know how frustrating that can be. With Squarespace, it's baked in. And with the built-in analytics dashboard, you can track traffic, engagement, and even revenue if you're selling something. Or you can use to figure out what landing pages are working and what needs to be improved. Whether you're building a site to showcase your portfolio or launch a software as a service that you just vibe coded, Squarespace makes it incredibly easy. Head over to squarespace.com/ArjanCodes for a free trial, and when you're ready to launch, use offer code ArjanCodes to save 10% off your first purchase of a website or domain. Now, back to the video. Now, the next thing I want to show you is a slightly different way of writing the test. So here, I also wrote the same test. Well, it actually checks for a different temperature, but it doesn't really matter. But it's using slightly different features. So as you remember in the original test with the monkey patch, we had to create a fake response class with methods and then return an instance of that class, which was kind of annoying. What you can do instead is using a mock. And the unit test module from Python actually has already nice support for that. It has a class called magic mock that allows you to do all sorts of cool things when you're writing tests. So here I have another version of that same test. And as you can see, there's still a function, a fake get. We're still replacing httpx.get with that fake get function. So nothing changed. We're still doing monkey patching here. But instead of creating this class with methods and everything, I'm now using the magic mock object. And As you can see, this is really easy to set up. So I create an instance of magic mock. I then set some values. So raise for status.return value is none. JSON.return value is, and then some JSON object. And then I'm simply returning this object. So Magic Mock allows you to set up an object with different kinds of methods and properties and responses in any way that you like, which is really good. And then I do the same thing, create a service, get the temperature, and then assert that it's 25. Now you might say, well, that's not that much easier than just using a class, right? But the nice thing about Magic Mock is that it also has assertions. And if you want to use that, you need to set up your test slightly different. So here I have another version of, again, that same test. But now I'm not using a fake get function, but I'm doing this slightly different by using the patch function from unit test. And then this is how you would do it. So I, again, create this mock object. I set some return values and other things that we're going to need. But then I'm using patch, which is a context manager, and I'm patching hpx.get with, and then I'm indicating what the return value is going to be, and that's this object. And then I also get an object that I can use inside my context. And this is where I can add extra asserts, which you don't have with regular classes. So here you see, again, I create the service, I get the temperature. So that's going to send me back the mock response when I call hpx.get. Then it's going to do an assertion that the temperature is 25, which is what we expect. But mock get has other methods that I can use. For example, assert called once. So now I can make sure that we only get the temperature once and that there is no double API request or something. And as you can see, if I type mock get dot, there's many other options here as well, which gives me a lot more control over what is actually happening with my mock object. So I can really inspect this in depth. And that's, of course, very valuable when you're writing tests. So this is why if you need some kind of fake object where you can create it yourself with a class, like I showed you in the first example, but using a mock gives you a lot more flexibility. The next thing that I want to show you that also helps you write tests more easily is by using something called a fixture. And a fixture is basically something that helps you set up and tear down states for your test. Later on, I'll show you how fixtures combined with parametrization can make your test even more powerful. But here's an example of how you can use a fixture in the test that I just wrote. So again, we have our test. And as you've seen in the previous test, the most work is actually setting up the weather service with the fake mock response object. And this is something that you can put in a fixture. And here's how you do that. Pytest has a decorator, a fixture decorator. And you put that on top of a function. So here a function WeatherService that uses a monkey patch. Then I'm defining again this fake get function, just like I did before. And I'm replacing HTTPX by fake get, and then I create the actual weather service. So this is a fixture that creates a weather service. And then the way I can use this in Pytest, I can simply pass this as an argument. And then the test itself becomes really simple. In this case, that's just a really simple assertion. But the nice thing now is that I can run different tests with that same object. So for example, I can run another test where what already generates something like this, where we try to get the temperature from a city that doesn't exist, and then it should get an exception. So also there, you can then reuse that object. And that's why fixtures are actually really powerful. Now, there's one more thing you can do to make your test easier. And that's actually, you can't always do that, depends on the code. But if you can, this is a really good thing. You can actually refactor your code to make it better, make it easier to test. Now, the main problem here with the weather service is that we have this direct call to httpx.get. That's kind of annoying. We have to work around that with monkey patches and mocks and whatnot. But what if you can refactor this so that you kind of take out this direct dependency on HTTPX and make it a bit more generic? And then the test also becomes a bit easier. How can you do that? Well, you could, for example, separate the HTTPX part into a client and then use that client instead. So in WeatherService, what I'm doing now is I create a WeatherService instance that has a client and an API key. And then when I get the temperature, I simply access this object. And the object is passed in via a dependency injection mechanism when I create the service. So now getTemperature no longer directly calls some function from some module, it calls a method on another object. And that object is something that you can replace or mock or anything. So that makes it a bit easier now to write tests for this refactored weather service. And here you see what that looks like. So I create first a mock HTTP client in my fixture. I then set the return value of get to some other object that has a raise for status and a JSON method. And then I return a weather service where I set that particular client. No need for monkey patching anymore. And now I can test this as usual by simply using this service that we passed as an argument. We got it via a fixture. So as you can see, there are different ways in which you can write your code and set up your test, and some are just easier than others. And being able to do some refactoring work to make your code easy to test is really helpful. Now I have a few more advanced Pytest features I want to quickly show you. But before we look at those, I want to help you take your own projects even further. And to do that, I've put together a free software design guide that contains the 7 steps I take whenever I design a new piece of software. It's very practical, very to the point. You can apply it to your own projects right away. You can grab your free copy at arjan.codes/design guide. The link is also in the video description. All right, now let's wrap this up with a couple of Pytest features you might not know about, a couple of hidden gems, so to say. The first is parametrization, and this allows you to test multiple inputs without having to write multiple test functions. You can see how that works. So I'm using pytest.mark.parameterize, and I'm parameterizing the city and the expected temperature. London 15 degrees, Berlin 20, Rome 18. Doesn't really matter what the cities and the temperatures are, but as you can see, we have multiple inputs here. We're supplying a list. And then in my parameterized test, I still get the monkey patch solution here. I could have also used the mock, doesn't really matter, but I'm passing the city and expected temperature as an argument. And now this test gets run with each of these different parameters. And I simply write the test as I would do it usually. So parameterized tests are really helpful if you want to test quickly multiple inputs without having to copy paste the testing code. Another thing you can do, and already sort of showed you that, is that you can run a test that a particular call actually results in an exception. And you can use pytest.raises to do that. And you can even specify the type of exception that you expect. So in this case, I have a fake response that there is an API error, and then we replace hpx.get by fake get, create the weather service, and then we check that indeed we get an exception. Now, you might say, aren't you just testing that your test code works? And that is kind of true, but in this case, it is of course possible that getTemperature maybe catches that exception or does something else with it. So the test is still helpful in making sure that if an exception happens here, that it actually arrives when you call the method. So pytest.raises, you can use that. Another thing you can do with Pytest is skipping a test. That's something you might want to do temporarily. Maybe, your test only applies on a certain platform, or it's going to be fixed soon. So you just skip the test for now, so you can re-enable it later. So that's mark.skip. And there's also a conditional version of this, skip if. And this allows you to, depending on some condition, skip the test. In this case, for example, if the platform is Windows, well, then we're going to skip the test because this fails on Windows. It's not really true. Assert true never fails, also not on Windows, but this is how you would typically use that. Finally, something you can do with Pytest is xfail. And that means you can indicate that you expect a particular test to fail. So the test is going to fail, but that's expected. It's not going to fail your build, but it still is going to show up in reports. So in this case, we know that there is some API bug, so this is going to fail. We still write the test for it, but then at least it's clear and it's in the report that way. these features are all very handy when you're refactoring something or you're working on cross-platform code. And they help keep your test suite green while you can fix things incrementally. Now, a few final tips. I typically try to keep a single assert per test. You want to keep each test focused on one outcome. Mostly that's a single assert. Sometimes there are multiple asserts if an object is complicated, for example. Another thing I do is I want my tests to be clear and descriptive. In this case, I'm calling this test get temperature with monkey patch because of course these are examples. But if you name the test clearly, then it's also easier in the report to see what you were actually testing. And finally, it's good practice to keep tests in separate files and also sort of try to follow the structure of your code base in your test file. So if you have source/foo/bar.py, then in your test folder, you're going to have test/foo/testbar.py. So that if you have your code, it's also easy to find the test for your code. And you don't want to mix your tests directly with your production code. These should be in a separate test directory. That's what I also did here in my code example. Now, I did put the code right here at the top level. You could also put that in a separate source folder, which might be a bit better. I kept it pretty simple here, but in a bigger project, that's typically how I would do it, a source folder and a test folder. Now, there's one thing you have to make sure you do. It's really important, otherwise your tests are not going to run correctly. In your PyProject file, you need to make sure to indicate what the Python path is. In this case, that's the root folder. If you have this in a source folder, then this is going to be source. But if you don't do that, then your test files are not going to be able to find the modules. It won't be able to find WeatherService, for example. For example, if I run test in the current setup, then this is what we get. And you also see that we get the skipped and the X failed tests right here. So you can see them in the report. And when I open one of the test files, then it has no issue importing the WeatherService. But if I remove this Python path from my PyProject file, and then I try to run the test again, then it doesn't work because it can't find the modules. So make sure to add Python path to your PyProject file, otherwise it doesn't work. But I'd like to hear from you. What are your favorite tips for writing unit tests? Do you prefer mocking, monkey patching, something else? Do you even write tests? Share your thoughts in the comments. Now, if you're working with VS Code like I am, it's important that you properly set up things for Python development. Otherwise, you'll be struggling with imports not being recognized by the VS Code language server or test files not finding the modules and so on. If you want to learn a simple way to do it right every time, watch this video next. Thanks for watching and see you next time.